All right. So before we get started on 3.2, any questions or issues with chapter 2 and stuff in Hawks? Okay. As far as I know, everybody's now actually in Hawks and working on it, which is good. I should have a review for chapters 1 through 4 probably put up beginning of next week in Hawks, so you can start practicing on that for your test. So the test is October 2nd. Yeah. So I'm almost sure it's October 2nd. Yes, it's October 2nd. So I'll have them put up next week. We're covering chapter 3 this week, chapter 4 next week. So, and then we'll do the test from 1 through 4 after that. As long as you've done the homework, it's going to be very similar to that. I'm just going to be pulling out probably about 15 questions out of that anyway. So it'll be 15 questions from those different lessons to make up the test. So nothing crazy that you haven't already seen if you've done the homework. Nothing that we haven't talked about in class. So, all right. Today we're going to start looking at visualizing data. Honestly, this is stuff that everybody in here has seen before and you've all done before. So this shouldn't be anything crazy. We're going to be looking at mostly qualitative data today. So these are things that we didn't do a lot. You're not going to be able to really do calculations and stuff on. So, and then we'll talk about quantitative data on Wednesday and how we can do some different types of graphs with those. So here's a graph. They say a picture's worth 1,000 words, and visualizing data or doing graphs of data helps that case. So the book had this at the beginning, and I actually really kind of liked it because it's different than what you would normally think of. Most graphs that you see are like the bar graphs and the pie charts, those simple graphs that show data. However, especially with the computers nowadays, we're starting to see a lot more artistic style graphs, like graphs that show a lot of data in different ways.
5,000 years old.
Not 5,000 years old. About 200 years old. It was 1812. So this actually shows the progression of Napoleon's armies from France to when he attacked Russia. The larger the bar, the more troops that he had. The brown bar is him going out to Russia. The black bar is him coming home from Russia. So you can see their path across Europe and into Russia, how his 425,000 troops got smaller and smaller and smaller. And on the way back, the black bar, he ended up coming home with only 10,000 troops. So it's just a really interesting way to visualize that information and how you can see it all. Like if we were going to take the same type of stuff and just give you it as a table with either days, weeks, or months and the number of troops, it wouldn't be as visual. It wouldn't be as impressive. Like you wouldn't really get a good viewing of that information. So I just thought it was a really cool graph, and it was interesting because like you can see this group broke off and then went home. They didn't even make Russia. So
all the things like
I think these are actually rivers. Yeah, I think those are actually rivers. It's supposed to represent Europe, but it's like it's artistic. Like these were done well before computers. Like this was done, I think, in 1869. So it literally was an artist's representation of what happened. But it's a really cool and interesting graph because we have some really interesting graphs that are coming out even now on how we can display data and look at data. So, all right. So the first thing before we can actually start looking at data and looking at graphs, we need to have a way to collect that information. The one way that we typically collect that information is known as a frequency distribution. So a frequency distribution is just literally a tabular form collecting all the data. All right, so these are two different types of tables. The first one has a lot more information in it. So the tables don't just have to be one piece of data. The tables can be multiple. So the first table is the population of individual states and the change in those populations from 2010 to 2016. And it's an estimate because we didn't know the exact population in 2016. 2010, we can get a good estimate of it because that's when we did the census. But 2016 is not. That's an estimate. This graph over here, or this table over here, is just a very simple one. This is a survey, and they were asking the number of people to pick how they would rate the quality of American public schools. Most of the time, this is the beginnings of value data. Once you get this table, then we can actually do some more calculations and work with it. Okay. So let's take a look at this one first. I don't want to delete that. So we've got this table. What's something we could do to this table that might make it a little bit easier for us to represent and understand that information? Yeah.
Create like a total amount of people. Like,
All right. How many people answered the question? Somebody add it up real quick. Here's the crazy thing. Nobody in here can tell me they don't have a calculator. Because you all have one on your phone. 1,200? Okay. It was funny when I used to go through school, the teacher would say, you won't have a calculator in your pocket at all times, so don't use a calculator. Now everybody has a calculator in their back pocket. All right, so we got 1,250 people total. Okay, so we've got the total. What else? So does that help me understand the data a little bit better? Would you guys be if I gave this to you and said, okay, now tell me what you know about the things, would you be able to do more than just tell me numbers that are on the screen? Okay, so what else would we want to do with it? Yeah. All right. So ratio would be a fraction, which would drive everybody in here nuts. Because I'm sure they're not going to want a fraction. How do we typically represent ratios and stuff like that make life easy? Right. We'd want to change it to a percent. Okay. So percentages. So when we change it to percent, that's known as a relative frequency. So this is the relative frequency. So same data. However, now that it's as a relative frequency, is it easier for us to understand and look at? Why? Why do percents make life easier?
It's a scale we're more used to than 37 out of 100 is easier to understand than 62 out of 12.
Right. It standardizes everything. When we're looking at it out of 100, it makes life easy. We understand that number. We typically understand how percents work. And like we look at, okay, if it's over 50%, it's over half. That's a majority. And we look at those, like if one was 4 and one was 18, okay, well, it's almost 5 times as much. That's easier to look at than 50 to 225. Okay, we have that scale to it. The other nice thing is because they're in percentages, we can easily compare it to other sets of data that might not have the exact same total. Okay, so if we did this problem again, but I only asked 850 people and only 300 said excellent, well, great. You might say, okay, just looking at those, the number went down, but it was out of less people. So in that situation, actually, the number went up. the percent went up. So it's like that's where having a percent allows us to do those calculations or do those comparisons a little bit easier. So changing them to percentages are very nice, and that's typically known as a relative frequency because it's relative to what the total would be. Okay? All right. Let's get rid of this. Okay, so here is another question. This one was, how serious is the lack of parental involvement with a child's education? They asked teachers, it'd be a lot closer to 100%. So we've got the frequency table right here. We've got the relative frequency table. And then we have this. What's this called? That is a bar graph. Okay. Everybody in here seen bar graphs before? Awesome. So bar graphs are a visual representation of our data. You do not need to have it in percentages to do a bar graph. We could have easily done the bar graph with these 700, 325, and it would have looked identical. It wouldn't have actually changed. The numbers at the bottom would have been different, but the actual length of the bars would have been the same. So is this a good bar graph? What are some things you can tell me now that we see in a bar graph as compared to just looking at numbers?
You can kind of see like a huge difference between most of the children's education.
Yeah, so there's a lot more in the very serious and somewhat serious than there is in the not side. So, and even very serious is like twice as long as the very serious, or the very serious is twice as long as the somewhat serious, right? And we can visually see that. Yeah. What's up?
I was also going to say like even though both of them, like both the percentage and the bar graph, you can kind of see the difference. I would say like the bar graph is way more, I would say, like measurable in a way.
Visually pleasing. Yeah, it's so we as a society don't like math typically. Like that's not something like, and we asked that question at the beginning. It's like, how do you, like, there's a lot of you in here that you're here because you have to be here. So we as a society don't like math, and that goes off to numbers as well. So when we see a bunch of numbers, it's like we kind of tune out. But when we see a picture, it's like, okay, I can deal with that. Like you can look at the bars and go, okay, I have some general idea there of what's going on. All right, and that's good. That's what people like to see. All right. Here's the bar graph. What can you tell me about this bar graph? Yes.
The length, well, the length between the percentage of, well, you can't see the percentage, but the agreement with the board, see how there's more Democrats than both Republicans and independent people.
Okay. So this says percent who agreed with the court. You don't know a court case. You don't know the numbers which side on purpose. I slid it off on purpose.
Yeah, no way.
Actually, no, I'll tell you the court case. The court case is fine. I slid the numbers off on purpose. So this court case is actually about Terri Schiavo, who was a woman in Florida who died in 2005. She was on a feeding tube. And there was a major court case where I believe it was her family. It was either her family or her husband. I can't remember which one it was. One of them wanted to remove her from the feeding tube and actually let her pass away, and the other one did not. And it ended up going all the way to the Supreme Court of Florida, who ruled that she could be taken off the feeding tube and let to pass away. So this is the results from that when they talked about, because when anything comes, it always ends up becoming political, and these were those results. So this is what we got. So based on that, you'd think, okay, Democrats were a lot more in favor of what the court decided getting pulled off. Republicans and independents were not nearly as happy about that decision. All right. Now we have numbers. But what did I say about numbers? People really don't like numbers, right? They're going to look at the graph. So I purposely hid the numbers because we're in a math class and you guys were going to instantly look at the numbers. So now look at the numbers. What's the bottom number? So everybody was over 50%. Everybody agreed with the court decision, or a majority agreed with the court decision. And the difference between 54 and 62 is only 8%. It's not nearly as drastic as it looked when I hid the numbers. Okay, so you can start to see how people could use a graph to influence opinion. Because when it's a picture, did they lie? Is this information incorrect? No, this information is completely correct. The data is right. I call it lying with statistics. You'll hear me say that a lot. It's the only math that you can actually manipulate situations with. So they use this data to manipulate a opinion. So they wanted to show the group that put out this graph wanted to show that Democrats were more caring and compassionate than Republicans and independents at that time for the family and the woman. However, they're all there. So this is the same graph, same data, but that goes to 0. Barely looks different at all. And actually, this one even gives you more information because it says there was a margin of error of plus or minus 7%. I said there was only an 8% difference between the top and the bottom, right? If you're plus or minus 7, that means they're basically almost the same. Or they could be based on the margin of error. So there's not much variance there. However, depending on how you show the graph, depends on who you're talking to, you can start to sway opinion one way or another. So when we look at graphs and pictures of things and not the actual raw data behind it or the numbers, you have to look at and make sure that the graphs are drawn in a way that are correct. Okay, not correct, because they're both correct, but drawn in a way that they are accurately representing the information. Okay, because like I said, most people aren't going to notice that that starts at 50. They're going to go, oh, that bar's 3 times as big as that bar.
I remember that case. It went on forever.
Oh yeah, it did. It went on for a long time. And it was like, and that's when we did this one, the same thing. We looked at that bar and goes, okay, that bar's twice as big as that bar, which I purposely said because I wanted to set the next straight. So yeah, that case did go on for a very long time, and it was heartbreaking. Unfortunately, sometimes I make the claim that we are more compassionate for our animals than we are for each other, in some situations. So, all right. So there are some things you want to do for bar. Do not sit there and write all this down. I'm putting this there so it's in the notes. So if you look at it later, it's in there, and I'm going to talk about it all. But do not try to write all this down on the screen. So there are certain things that are the proper way to draw a bar graph. The first thing is it can be constructed horizontally, vertically. Typically, we're looking at when they're more descriptive, you typically will do it horizontally because you can easily put the information there. It really just depends on your preference. So vertical is more for numerical ones, but again, we saw graphs that were horizontal and vertical, both for actual numbers. That doesn't make an actual difference. Categories that have some order with it should maintain that order. So if you're doing time, for example, keep them in order of time. Like don't put 1990, 1980, 2000, 2020, 2010. Like, and there's people that will do that to show a pattern that doesn't really exist. So if there is an order associated with it, you want to put that stuff in order in that way. If we're doing all states, listing it alphabetically doesn't really matter. That order doesn't matter. So that goes back to where we're talking about like nominal data and ordinal data. If it's ordinal data, keep it in the order that would be effective. If it's nominal data, it doesn't really matter in that respect. Your other categories should always be listed at the end or on the bottom, depending on how it's actually listed. So it should be outside of the actual data, even if it's taller than some of the other data that's there. All right. 2 more graphs. I'm a boss that wants to fire Susan. Which graph am I using?
0.23.
This one, the right one. Okay. So are they both graphs showing the exact same data?
Yeah.
Again, one just starts off at a different number. So it's accurate. I'm not lying about the data. I'm not changing the information. That's how much Susan sold. But I would say she's Rob is twice as good of a seller as Susan is. Look at the data graph. And Susan's going to walk in with this one. Go, I'm basically the same as Rob. So just keep those things in mind when you're looking at some graphs. The other thing you want to make sure of is that the bars are the same, like the same widths. If you're using color to do your graphs, make sure that the colors they don't take away from the actual data. We tend to look at things that are black is tall, like they stretch a little bit more, white is narrower. So like if you're using graphs that change color, that can affect people's visual perception of the data and the information. So there's lots of little tricks that they use to show this type of data and show how it's more confusing than it actually should be, or to influence your decisions. All right. Next type of graph. I didn't actually know this was a type of, like, an actual name for a graph until I saw it in the book. So do not worry if you never actually heard of this graph before, but you've seen it. So this is known as a Pareto graph. All it is a graph that is arranged in descending order. So you see that nice curve. All right. So what types of information do you get from this graph?
India, the US, and China have a lot more cinema attendance than the rest of the world.
Yep. Okay.
And India has a lot more than everyone else also.
Yeah, India's way up there. Okay. Are these graphs in percentages or just raw numbers? They're just raw numbers, right? Okay. Would percent show a different type of graph? Would that change how the data is looking at? Anybody know off the top of their head how many people are in India?
Probably a lot. Like a million.
It's like 1.3 billion people or 1.4 billion people. How many people are in the United States? Like 330 million. So if we're looking at this in terms of percent of population, both the United States and China are above their actual population, which means people there go more than once to the movies. So if we're looking at it in terms of percent of population, the United States would be first. So it depends on how you look at the data, how you want to actually understand it, and what, again, you're looking to sell. This one, they were just showing total number of sales. Like these are probably ticket sales that they were looking at. So, but if you're a movie exec, where are you going to focus your energy? India, United States, and China. That's where you're going to focus your energy for your movies to fit those type of markets. Most of the movies made in the United States do not typically do well in India. They have their own Hollywood. They have their own style movies and stuff like that that do quite well in India, not really outside. Everybody's trying to get into the China market, though. All right. This was the Winter Olympics in 2014. The book has old data. I didn't find the graph for this year's data. Sorry. All right. What do we notice about it?
Russia won the most medals.
Yep. Russia won the most medals. Russia won the most golds. These are actually sorted in terms of gold medal wins.
The top three countries are very known for their colder climates,
Mm-hmm.
and the US also has some colder.
Yeah. US just has a lot more people that go to the Olympics.
Yeah.
This Olympics actually was in Russia, so that tends to have an impact on who's doing better or worse. And
Well, I guess you don't get the climate from the graph, so it's just.
well, yeah, it's gonna go off in a second. There we go. All right. So is this graph or this graph easier to read? Do they show the same data? Mhm. What's this called? It's a bar graph, but it's a special bar graph. Starts with an S. It's stacked. So a stacked bar graph uses basically totals things. So we're stacking the information on top of each other. So this is showing the total metals one split out by each of those categories. So you can see who is a little bit higher and stuff like that over in total metals, but it also makes it a little more manageable to look at than the first graph. The first graph, the bars were a little skinnier. There was a lot more of information on there. So stacked bar graphs help you understand or see that data a little bit better. But it also it's a different type because it also shows you the total and not necessarily the ones by each type. Like this one, it's harder to figure out how many bronze medals people won in this graph or silver because it starts off with the gold. So. All right. Is this a bar graph? Yes. Okay. So this is the percentage of neighborhoods that have and the percentage of whites in a specific neighborhood. So the higher the bar, the more of those neighborhoods exist. The further to the right on your side, the more white they are. So that's 1980. That's 2000. And that's 2017. So what kind of, so these are bar graphs showing data. What type of data is this? Is it a time series or a cross-sectional? This is a time series because we're looking at it over time. We're looking at the same type of data over time. The way they graphed it is a bar graph, but the actual three graphs combined make a time series. All right, so what are some things we notice? Are these graphs created unbiasedly? Not in a way that's supposed to influence a way that you're supposed to think about it. Does it start at 0 on both sides? Okay. What about the colors? They change, right? They're changing from a blue to a yellow. Okay. Are they more neutral colors? Which one's a happier color? No, yeah, if you're looking at the colors here, which color would be happier, yellow or blue? Yellow. So when you're looking at graphs, when you're looking at data, like these are all graphs. So the New York Times has like 60 graphs to look, like they're just all crazy graphs and everything else. So it doesn't have like a list. Here's all the things you should talk about. But all these things matter when you're creating something. When you're trying to create a visual, colors matter, text matters, the font size matters. Okay, so when they throw these three graphs together, notice most of the font, like the numbers and stuff, are very small. They're wanting you to look at the visual and not really look at the thing. But colors also matter. And blue is typically not a very happy color. They're neutral colors. These are colors we use all the time, but blue is a little less happy. Yellow is happy. So it's like they're like, wait, it's getting less yellow. It's like, so if you're not looking at necessarily what the thing is talking about, you're just looking at the data, you're like wait, this is not a good thing. It's like, so, and typically if you look just at the numbers, you want to get close to 100%. So we'd want more over here. Well, not necessarily the way that it's looking. So you have to start to think about how they're doing these. So the numbers and the stuff behind it don't change, but their visuals can change. And that can make a difference. All right, let's see if I can find another one on here. I don't like that graph. We looked at that one last time. That's the. All right, we'll look at some more of those afterwards. They have some really cool graphs on there. All right, another type of graph. A pie chart. Everybody knows what a pie chart is? Everybody seen a pie chart before? All right, so a pie chart has very specific criteria. It has to be made of pie. Yeah. So a pie chart takes it has to be in percentages. Okay, and those percentages have to add up to 100%. You should not have a pie chart that doesn't add up to 100%. Okay. So we need to do that relative frequency part to do a pie chart. Okay. So here is two sets of data, both showing the exact same thing. One is a bar chart and one is a pie chart. Which one's easier to understand and read? The pie chart. Okay. This is our budget for 2015 for the United States, the federal government. That's how much money they spent. $3.36 trillion in 2015. And that's where all the money went to. Okay, Social Security and Medicare are the highest. Social Security and Medicare is supposed to be paid through, which is your payroll taxes. There's two different types of tax. Well, actually, depending on how you look at your payroll, how they break it down, there's two or three. Your income tax is one tax. Your payroll taxes are your Social Security and Medicare, which probably is listed as FICA, F-I-C-A. You only pay half that tax. Your company pays the other half. So if you ever wanted to be unemployed and work for yourself, you have to pay both. So they've changed it. It used to be 7.5%, but I know it's less than that now. So it used to be 7.5% you'd pay, and they pay 7.5%. I think it's down to like 6.25% now each side. So the amount of tax went down, but the spending of that has not gone down. So therefore, that's why we're having so much trouble with Social Security. That should match. The amount of money that comes out should match what's going out in Social Security and Medicare. It is not. So that's why we're having trouble. That's why hopefully Social Security exists by the time you guys retire. Huh? Yeah, exactly. So that's the spending. And this is the revenue. So this is where the money's coming from. So individual income taxes, payroll taxes, that's your FICA and Social Security. Corporate income taxes, other taxes, and excise taxes. Those are like your capital gains and those type of things that are there. So, but notice $2.96 trillion. $3.36 trillion, which means we did not bring in enough money to pay for what we spent. Therefore, it goes to the deficit, which is increasing exponentially on a regular basis. Go there. Let's see if I can find the. I had it
That
earlier.
Wackadoodle one with all.
Oh, I'll show you that one in a second. I want to find a nice one. Problem is they don't make them as nice pie charts anymore.
No, they clear them out into like pieces out in the wild.
Yeah. They do this now. This is actually what the government actually sends out now.
Oh,
So this was 2023. These are actually not pie charts. These are bar graphs. They're just curved. They're a stacked bar graph. Because there's your mandatory, discretionary. So they're stacking that information. And the same thing with revenues. So this is actually a bar graph, not a pie chart. But it does show how much we're spending. Notice that in 2023, our outlays were $6.1 trillion, and our income was $4.4 trillion. So the gap's widening. But these are ways that they start to show that information to be able to, like, so mandatory spending, that's your Social Security, your Medicare, Medicaid, those type of programs that they have to spend. The discretionary, that's where your budget, that's where the federal budget comes into play. So that's that discretionary funding. Your defense budget and your non-defense budget. Non-defense is everything except for the military. So there's your Pentagon budget, and there's everything else in the United States government. It's about the same, which is not a good thing, depending on how you want to look at it. Income taxes, payroll taxes, same concept, they broke down. So this time they did other, as all the other ones, they didn't break that one out in this graph. All right, pie charts are nice. However, you can get crazy with pie charts. So this pie chart, really nice. Percentage of employees. This chart, not so nice. Okay, so pie charts are really good when you're looking at small pieces of data. Okay, you don't want to necessarily have a bunch of stuff on there because that changes perception. Like it makes it really hard to see the data, and the point of them is to make sure you can see the data a lot easier. So, all right, let's look at another pie chart. Okay. Is this a good pie chart? It is a good pie chart? Okay, why is it a good pie chart? You're right, it's not 100%. This pie chart's over 100%. So the next question is, okay, they are over 100%. Are they representative? So are the slices representative of each other? So are they proportioned correctly? Yeah, the 7312 is a little bit bigger than that one. That should be that. That's the smallest one. That's much bigger than that one. So like if you kind of look at it, they kind of are proportional. So it's not horrible in that respect, but they definitely add up to more than 100%, and they shouldn't. However, why do they add up to more than 100% in this situation? Exactly. You can use multiple. All right, this was what app do users use each week? Well, and I bet most people use all those apps pretty much every week. Maybe not audio, maybe not listen to the music and stuff on their phones, but they definitely use other ones. So that's why you can use multiple ones. So This is not a good use of a pie chart. Okay. Trying to find another one. There's one I would to use and it doesn't. USA Today is horrible with their graphs. Okay. And I can't find the one that I'm looking for now. That's okay. Nope, can't find that one. All right, let's look at some other graphs. Let's see. I want share. Here's a nice little graph. This is actually a variation on a Bart's graph. It stacks, it builds up, so that tells you, it's supposed to show you what the total percent of energy usage is. And it's going over time from 2001 till 2017 on this graph. So you can see where our energy is coming from and how it's changing. We're using less coal, more natural gas. Hydroelectric stayed pretty much the same. You would look at, does nuclear stay the same or does it go down? Where did nuclear start? And where nuclear ends? But the way this graph looks, it looks like it dropped, right? The way they drew it. Where it basically is the same.
Where are the small ones on the bottom? I can't see.
Hydroelectric, wind, solar, and petroleum or oil. So we don't typically use a lot of oil for energy production. Most of it comes actually from natural gas and coal.
Oh, what's that place in Pennsylvania that's still burning in coal?
I can't think of the name of the town.
Starts with a C, I think.
Yeah, I was actually, so when we drove cross country, I was actually I wanted to stop there, and then the two other people in my car told me no.
Oh.
I'm like, fine.
That's like on my bucket list. I want to go right on the highway.
Yeah.
Spray paint on the highway. That was there.
This is another fun type of graph. So not necessarily a bar graph or a pie chart. It's one of those little bubble graphs. So, but you can definitely see that it's designed to show you the gap between them. However, the United States and China, so the United States at 596, China's at 215, right? Are there bubbles proportionate to what they are?
Well, maybe actually because the area is weird.
Right. And that's the thing. They probably are. Actually, it's probably just about double because of the area. However, visually, they don't look that way. It's like you'd expect it to be bigger. And that's one of those things when you're looking at it, you'd expect, like area is weird, especially with circles, it's harder to see. But like you'd expect it to be bigger than that. So some of the little things to think about. Let's jump up. I really like these graphs.
Have you ever seen the like Verizon map where like the entire US is filled out except for Nebraska? It perfectly goes down.
Well, they're the only state that doesn't have like no connectivity.
Apparently not Verizon. These graphs are typically known as heat graphs, not necessarily heat in terms of temperature, but heat as in terms of it's a scale. So if you look at the very bottom, it goes less popular, more popular, that's the heat scale. And they're done by county typically in the United States. So you can see it's changing on your screen, but not mine. So we've got Rihanna, Drake, Taylor Swift, and Luke Bryan. So you can see where they're more popular. It's funny that Drake's more popular in Texas than Luke Bryan. I would not have guessed that one.
But Luke Bryant is on the bottom.
Yeah, Luke Bryan's down here.
So he's popular like really everywhere.
Yeah, it's probably yeah. So
Is Taylor Swift?
this one.
Yeah.
So Taylor Swift is popular everywhere except in the South, the Bible Belt.
What was
So-
the top one?
Rihanna.
Okay.
Rihanna was the first billionaire musician. So, like the thing. So, but you can start to see the different types of heat graphs to actually see that types of data. This one here is a stacked line graph, but you can actually see it as it's also kind of a bar graph. If they split it up, it'd be no different than the stacked bar graphs. But this is a stacked line graph because the bars are so close together that they actually merge. So you can see that progression over time. So in this case, you can see how much greenhouse gases and where they're coming from. So passenger vehicles are the most, and trucks and trains, planes, ships, and everything else is up here. So even though we think like a plane uses a lot of greenhouse gases and stuff like that, and uses a lot of gas, however, there's not as many of them, and they also transport a lot more people than a specific car does. So there's a lot more cars in the United States, and that's where the greenhouse gases come from. Music fingerprints. Air traffic control over Thanksgiving. So everybody goes. It's like the most seem to go to Miami. Like all of the big ones: Boston, leaves, Washington, Atlanta, all going down to southern Miami for Thanksgiving. Guess they want to go to where it's warm. What's wrong with this graph?
The topic or just like the graph itself?
Well, the graph itself.
Was it 30%?
It does. So it's showing middle school and high school. So this graph, what's this graph? What do you think the purpose of this graph was? Okay.
Comparing middle school to high school.
I would say comparing middle school to high school, but I think it's also looking at e-cigarettes specifically. But are e-cigarettes part of any tobacco product or are they separate?
Part of tobacco products.
Right. That's the thing. And the way the graph goes, they're together. The any tobacco product includes the e-cigarettes. It's not a separate thing. So when you're looking at, depending on how you're looking at this, you go, okay, well, e-cigarettes are still a lot lower than everything else. Well, yeah, because it's included in it. That's why that tobacco product line kind of mirrors the e-cigarette line. So as e-cigarettes goes up, the tobacco line goes up because it's included in that part. If they listed e-cigarettes and cigarettes or chewing tobacco, stuff like that, that's where you start to see that e-cigarettes took off a lot. It was a lot higher than other products. So you can start to see how people use different graphs. So remember we were talking about the drug trials and how fast the COVID vaccine got and everything else. So these are drug trials. So if 100% of drug trials are proposed, only 10% of them actually get approved. So 90% of the trial that they want to do are denied. So, and there actually is, if you see, there actually is another bar that says failed in each one. So you can actually see the percent breakdown. So that's why it was so crazy that basically almost every COVID vaccine that came out was approved for trials. Because it's not typically that way. I haven't looked at most of these graphs, so. This graph shows the percentage of American teenagers 13 to 17 who feel certain problems are major or minor among people in their age group. This was done from September to November of 2018. I'd be interested to see this graph done again. So, what kind of graph is this? This is a stacked bar graph. What should each graph add up to? It should add up to 100. Do they? No. So, I mean, some people just didn't answer the survey. So, that'd be the variation in those.
Oh, we have
Really small.
That's confusion.
Percentage of people who got more of the same or less education than their parents. What kind of graph is this over here? Another stacked bar graph. Now these should add up to 100% because you really have to be in one of those three options. Let's see, where are we? There we are. Huh? They don't? What's it? Oh, you're right. It's off by 1%. It's probably a rounding error in it. So, what can we make about this graph? So this was done in 2012. So if you're looking at the populations of the countries, why do you think the United States is so low? It's expensive.
Maybe because the quality of education in the United States was already pretty
Yeah.
good, so it's less likely that people are going to get even better.
So in 2012, if you were going to college, let's say we'll make this easy. We'll say you're 20. So that means you were born in early 90s. So that means your parents were born, or your parents were in college probably in the 80s, maybe early 90s. So the education hasn't really changed much in the United States since then. In South Korea, it is drastically changed since then. Their society has gone under a major improvement in the past 20 or 30 years. So that's why we would see that difference there. So, but that's the thing. It's like when you start to look at the data, it's like, oh, the United States is way down here with Estonia and Slovakia. It's like, well, yeah, there's reasons for that. So a lot of these were still in college. It didn't say, notice that nowhere in this does it say they had to go to college. It just says got the same education as. So if your parents graduated high school, if you're in the middle, you also graduated high school. So if you went to college, you would that. So the less one would be like you didn't graduate high school if your parents did graduate high school or not. So that's where like Estonia, most of them probably just graduated from a technical school. So they might not have gone on to college, stuff like that. But they did the same, so they're good. So it's that type of information. Percentage of people who obtained education beyond high school as of 2014. Now this is where we should be a little higher than that. But what do you find interesting about this graph? So these are the percentage of people who attained education beyond high school as of 2014.
Separated by gender.
It is separated by gender. So what do we notice about the gender though?
What women are going to.
Universally, every single country, the women are higher than the men. Which is not what a lot of people would have automatically assumed.
Yeah, you would think that the men would have been going back to school.
Really nice little bar graph. This one. So traditional sales would be anything other than streaming. So that you bought the CD, or now vinyls are coming back. Or I would assume that also means if you bought it digitally. This would be if you're just streaming on like Spotify, Apple Music, things like that. So people who like rock seem to actually buy their music more often than stream it, apparently.
Sounds better on vinyl.
I like vinyl just because of the graphics on them.
Yeah.
I stream most of my music. It's just easier.
It is easier. You're right.
All right, last graph we're going to look at. Yearly war-related front page headlines. No. These are not percentages because there's like 75 headlines, 50 headlines. Huh? I don't know. It doesn't say. So I don't know if that'd be how many days they were on the front page. I'm going to assume this is actually New York Times because this is the New York Times graphs. So I'm going to assume this is the headlines of the New York Times. So I would assume it's per day, but it doesn't actually say. So, but what do you find interesting?
The overlap on Afghanistan, Iraq.
Yeah, the amount of, well, over in general, like the number of headlines dropped, right?
Until you get to
It went up briefly right when it first happened. I think if you look at the years 1, 2, 3, 4, yeah, that's right when we invaded Iraq was in 2004, actually.
I mean, it didn't go up a lot when we invaded the Gulf in the 90s.
No, it didn't. So we look, it's constantly going down over time. Like World War I, even World War II, like that was a major war. Like, and newspapers were still a big thing back then and whatnot. So the headlines went down, but we also have to look at these are only newspapers. So yes, newspapers were big. What was a big improvement in society between World War I and World War II? Radio came out. So the radio really had more conversation, more things. And cinema came out. People used to go to the movie theaters to get their news. Right before the movies, they'd play roles, the news correspondents. Then we had Korea and Vietnam. TV started becoming a lot more popular. And then now we have the internet. So that also might have an impact on the number of stories that we're making the frontline head papers, because there's other ways people consume news now. We don't typically get a newspaper. So they were talking about how, and this one came out and says, why Afghanistan became the invisible war, where nobody was talking about it. Well, I think more died in World War II than World War I, but I'm not positive. Let's see. Nope, we did. Wait, hold on. We had total U.S. deaths total. World War One, 201, 204,000. Yeah, we had more deaths in World War II.
Probably more deaths in Vietnam than Korea as well.
No, actually, Vietnam was lower.
Well, I think, like, probably more people died in Vietnam than people died in Korea.
Oh yeah, yeah. Vietnam had 153,000 people. Korea was a weird war because it's still technically we're still at war with Korea. Korean War has not ended. So, but it's part of it. But I think the diversification of media also plays a role in it, and that's where it's like when we're looking at graphs, like you have to look at what they're having. Like this was put out by a newspaper to show how we're not talking about it anymore. It's like, so little things like that. All right. And in that regard, we're done. Next class we're going to talk about, we'll cover 3.3 and 3.4, which will be more of the quantitative graphs. We've done 3.1, 3.2, and mostly 3.5 because that's looking at the types of graphs and stuff like that. So those you should be able to actually do in Hawks. And we'll cover 3.3 and 3.4.